Hello, here I'm presenting low temperature DSC tester from AHP Plastic Machina. This type of cooling system is actually liquid nitrogen cooling. It has a reservoir of 10 liter of liquid nitrogen. Of course, in this method for cooling, you will have consumption of the liquid nitrogen, and you need to have a big reservoir of the liquid nitrogen at your laboratory anytime you need. You need to charge this 10 liter liquid nitrogen reservoir. You can open the lock door, and you have the pumping system. It's like this. You have two sealing system here. When I'm turning this knot to right, it will shrink these O-rings, and these O-rings will touch the neck of the reservoir and will seal it. You will first of all, you need to use safety glass, because liquid nitrogen is absolutely dangerous for your eye, and for long time touching of liquid nitrogen is of course it is dangerous for the skin. Put it like this into the reservoir. Yeah. Then turn this knot to right to fully tighten. Be sure that it's tightened fully. Yes, now it's ready. Here you have a connection of the valves. You have two valves here. First one is for the coolant out of the liquid nitrogen reservoir, and that is connecting to the cooling head using this hose. This is a special hose. Coolant in. You also have the same label here. Connect this hose to this connection. This is coolant in. This is actually inlet to the cooling head. And you have another hose that is outlet of the vapor of the liquid nitrogen, that is actually nitrogen gas. You will put this hose out of the laboratory. Yes? And just for now, for testing, I'm putting it here. I will show you the liquid nitrogen vapor that is actually a nitrogen gas and will be going out of the laboratory. Here you have another valve. Whenever the cooling process starts, these two solenoid valves will be opened. The first one is in the top. The connection of the air will be coming here. This is a 6 millimeter air hose, compressed air connection, and it's here. I'm connecting 6 millimeter air connection. Before connecting this hose to this fitting, you need to set the compressed air pressure to less than 1 bar. That is less than 0.15 megapascal. I'm connecting this to a quick connection. Yes. This is flow adjustment. Be sure that it is open. Whenever the cooling process starts in the machine, these two valves will be open. The air will be, compressed air will be going to the top of the liquid nitrogen, and the liquid nitrogen will be pumped to inside of the cooling head. And these two valves will be working together. And there is a one connection here that is going, that is a quick connection named valve, and is going to the back side of the machine. Is here. Yeah, it's valve connection and coming to here. And also you have 3 flow meters. You will see the writing, the labels of the flow meters in the back of the flow panel. N2F out, N2F in. This is nitrogen flow into the test cell. The other one is oxygen flow into the test cell. The middle one is the nitrogen that is used for homogeneous cooling of the DSC cell, and it's being charged surrounding the DSC cell for uniform cooling and for having the best baseline of the DSC cell. Yes, and the connections, you will see the same writing here as in the back side of the machine, and you will connect these 4mm compressed air hoses to the back of the machine, and the labels are the same. I mean, here you see N2F out, and you will see the same label in the back panel of the machine, and you will connect the hoses to the back. It's easy. Then the power is 230 volt, 220 volt, 50 hertz, single phase, and it's coming here. The other connection is drain. For drain out of the water, that will be the defrost water on the surface of the cooling head and will be coming out from the back side fitting, and this one is the drain out. You can put a compressed air hose here and put it to drain. The connections are like this. The regulator, pressure regulator, double gauge pressure regulator. First one is showing the pressure inside the balloon gas. The other one is the outlet pressure. You will adjust you will set the outlet pressure using this valve. Turning to left will reduce the pressure. I'm showing you. It's like this. First, put this valve to open position. That is, turn it to left to have loose valve, and now it's closed. The valve for the regulator is closed. Now open the main valve of the balloon gas. You see the pressure inside the gas balloon. The outlet pressure setting will be done here. Just bend the hose and turn the valve regulator to right and set the pressure to something about less than 2 bar. The black writing is in bar, and it should be less than 2 bar. 1 bar, 1.5 bar is enough. Yeah. Then you will see the gas coming out of the balloon gas, then connect it to the fitting. You also have the same setting for the regulator for the balloon gas of the oxygen, and will be going to the back side of the machine to the inlet of oxygen. Before starting the test, you need to open this valve, because when the cooling process starts, it will be freeze and you cannot open and close this valve. It should be opened in the beginning of the test. This flow valve will be opened, and this valve is for pressure adjustment of the air that we are charging to the balloon gas. The other one is safety valve, and will be opened. The valve will be opened in definite pressure, that is something about 2 bar. It will be opened automatically to release the pressure in the top side of the liquid nitrogen balloon. And here everything is ready for testing. Before starting, I'm just opening this valve, turning it to left, and the regulator pressure adjustment will be 0. Yes. Now everything is ready for test. Here you have the process. For example, this is an example of the process we can set in this machine. For example, this one is graph like this, that you have the temperature here, temperature rise, the first level of temperature, and also you can set the rate for the temperature increase. Then you have isothermal section, and then you will have cooling section. I'm just setting the parameters here, setting the first temperature to 210, the rate to 20 degrees centigrade per minute. Time, I'm just setting it to maybe 5 minutes. then going down to minus 30 degrees. That is the limit temperature, limit down temperature for this type of the machine. You know, liquid nitrogen cooling is capable of cooling the head down to 130, 150, 120. Also, you can set the parameters of the machine to lower temperature, to higher temperatures like minus 30, minus 50. This one absolutely depending on the customer request. And the higher temperature limit for this type of the head is 400 degrees centigrade. Up to 400 degrees centigrade, you can use this type of head. This cooling head is capable of temperature range of minus 30 and plus 400 degrees centigrade. You can use it at the same time, but for long time testing, for example, if you want to use this head at 400 degrees centigrade for a long period of time, you want to use the head to higher temperature limits, you can open the cooling head and use the standard cover for the DSC cell. That is special for the higher temperatures, and you can use it at the higher limit of temperature for long time. It's easy. You can open these four screws here, then move the head up and replace the standard plus temperature sleeve for the test cell, for the DSC cell, and it's easy to replace it. But for normal standard use, for example, plus temperatures of 210, 250 degrees centigrade and down to minus 30 degrees centigrade, you can, of course, you can use this head at the same time for plus temperatures and minus temperatures. Now I just set this example of the program here. I'm just setting the gas to nitrogen because I only have nitrogen gas connection here available here. The temperature will rise to 210 with this rate, will be remained in isothermal mode for 5 minutes, and then going down to minus 30 degrees centigrade. Cooling graph will be on, and the delay here I'm setting to lower seconds, maybe 5 seconds. This means that after temperature reach to 210 degrees centigrade, the timer will be count down and from 5, and after it getting to 0, then we'll go to the next step, that is isothermal step. This delay is for stabilization of the temperature at the defined temperature set value for the first level of temperature. That's all. It's easy to set here. Then everything is ready to start. I will show you how it works. Yes, I'm starting here. That's all. I will show you the process of cooling of the machine. For the graph, you can put it to the definite level, maybe 500 degrees centigrade. The other one to minus 50 degrees centigrade. Also set the limit for the DSC value, maybe 200 and minus 100. The red one is DSC value. The blue one is temperature value. I will show the nitrogen automatically opened because we set it here for nitrogen gas. And you can set the flow of the nitrogen. You can see the flow meter for nitrogen, it's here. You can set the flow here, and I'm setting it to 50 milliliter per minute. Yes. And it will be continuing, and you can set the time scale here to auto scale. Now it's auto scale, will be moved automatically. You can click the auto scale off and set the time here, definite time, maybe 30 minutes, whatever you want. Yes, you will see the red as DSC graph. Now I don't have any sample, and I will show you the graph after the temperature get to the first level of 210 degrees centigrade. Now we just put the sample here. I'm just showing you here the left. Just please show the head here. The left sensor is sample. The right one is reference, that is empty. That is empty pan. The left one is pan with a sample piece. Here we set to 210. After the temperature stabilizes in 210, it will be going on as is isothermal for 5 minutes. You see after the start is marked here, after 5 minutes, that is 15 minutes. When it's coming to 20 minutes, it will switch to cooling. I will show you how to control the cooling, pressure and rate. Now the cooling is on, the cooler is on. The pressure valves, as you see, the valve for the air supply and valve for the coolant is on, it's magnetized. The valve, manual valve, is open. And looking at this gauge, just set the pressure, turn the regulator, pressure regulator to right, and you can start with 0.05 megapascal, that is 400 millibar. Here you see 0.04, and I'm just setting the pressure. That is 0.4 bar or 0.04 megapascal. I start the cooling with this pressure. You see the coolant is going into the head, from this valve going into the head, and just in a minute you will see the defrost of the condensation. You will see the condensation here in the inlet valve. And the liquid nitrogen going to the head and going out using this hose as a vapor of liquid nitrogen, that is nitrogen. Be sure that you will take this gas out, because in the small rooms, if you do like this, you will have lack of oxygen, and it's dangerous for the safety of the operators. Then be sure that you will put the outlet hose of nitrogen gas to the air. You see the temperature is going down here, and the temperature we set here is -30. I want to show you the scan of DSC from the 210 degrees centigrade down to -30. For the rate of cooling to be increased, of course, you can raise the pressure here. Now the pressure is 0.04. If you increase the pressure to 0.06, that is 0.6 bar, that is 600 millibar, the cooling rate will be raised. And you see now the cooling rate is increased, and in a minute you will see the condensation of the air also on the outlet hose. You also have another parameter for cooling here. The middle flow meter is cooling, that purge the nitrogen gas from the balloon to the surrounding of the test cell. With increasing this flow of gas, you will increase the cooling rate as well. I'm just setting to 200 milliliter per minute to have higher cooling rate, higher heat transfer at the surrounding of the DSC cell. Now, after about 10 or 15 minutes, we will see the graph, how it looks. That's all. It's easy to use, and this is DSC with minus degrees centigrade from AHP plastic machina, made in Turkey, and The test setup is the reservoir for the liquid nitrogen, the connections, the pump system for liquid nitrogen, the cooling head, the hoses, connections, flow meters for the atmosphere inside the test cell, and for the cooling gas, that is nitrogen. And that's also, it comes to you with the standard cover for the DSC cell, that is for positive degree, only for positive degrees centigrade. You can easily replace the head, the cooling head, with the standard positive degree, high degree centigrade of the cover for the DSC cell. Thank you. At the end, I will show you the graph, how it looks, the cooling graph, how it looks when it comes to the minus 30 degrees centigrade. I will show you the DSC graph. This sample is specifically HDP. You see the melting peak here. Also, in the cooling process, you will have the crystallinity, the DSC graph, that is red one. I will show you at the end when it catches, when it gets to down to minus 30 degrees centigrade. Thank you. Now you see the graph here. We just sweep the temperature from something about 40 degrees centigrade up to 210. Wait for 5 minutes for isothermal, then going down to HDP. The sample material is HDP. You see the melting peak here. Here in cooling process, you see the crystallinity peak here. This one is crystallinity peak, that is positive. The melting is negative. And the cooling, and here you see the very good baseline for the DSC cell, and the temperature is going down to minus 30 degrees centigrade as we defined here. Thank you for your note. This is DSC machine from AHP Plastic Machina with low temperature cooling system, that is liquid nitrogen, along with all attachments. Thank you for your note.